Hi guys and welcome to the video. Today we're going to be talking about searching algorithms, that is under the GCSE Computer Science subject in accordance with the AQA exam board. In the top right hand corner you've got the usual reference to the exam specification referencing what will be covered in today's revision video. Just to begin with, if you haven't watched my representing algorithms video or my efficiency of algorithms videos yet, I suggest you go and do that first, as this is more of a continuation of those two. If you have done, then great, we'll pick things up straight away. But just as a piece of advice, please do go and watch those videos first, as they will put you in a better place, and this will just make a little bit more sense. So we're going to be looking at types of algorithms today, and the first one we're going to be looking at is a type of searching algorithm. There's two actually we're going to be focusing on. And the definition of a searching algorithm is that it's a logical process to determine whether the search item, which is a user-defined value, exists within a collection of data. And the two we're going to look at are both a linear search and a binary search. Now, the linear search is the first one. It's considered to be the sort of brute force, if you like, search that we can carry out on a collection of data. The user specifies a search item, and then we go through the list of data, one item at a time, looking at the items to test whether or not they are what we've been asked to look for. There is a massive benefit to the linear search, and that is that it will perform the search on any data set because it doesn't require the data to be ordered. And so if you've got 10 items that are in a random order, they're not in ascending, descending, sorted by type of value, whatever, it's going to go through every single one of those and check for the presence of what it is you're looking for. There is a bit of a concern here in that if you've got 1,000 items and you're looking for a value that just happens to fall in position 1,000, you are going to have to check 999 of those values unsuccessfully before you end up finding the one you're looking for. So there is an issue around speed when it comes to linear search. Now, I've put together this piece of pseudocode for you, so you've got actually an algorithm to maybe flip into some programming language of your choice, Python, VB, whatever it's going to be, after this video. And I'm just going to talk you through this briefly. I've got a list of items which hold some values. I've gone with months of the year. You'll notice that they are unsorted. They're not in any ascending order in accordance with their first letter or anything like that. I've then got a search item that is specified by the user. I've then got a found variable, which I'm using as a Boolean flag. And I've then got another variable called position, which I'm setting initially to 0. I then have the commencement of an indefinite loop. The condition for my loop is that position has to be less than the length of the items that I have, and that found has to be equal to false. The reason for that is because once the item's been found, I then flip found, reassign found to being equal to true, and there's no point in continuing to search for something if you've already found it. I then inside of the loop have a selection statement which checks whether or not my current position within the list is equal to my search item. If it isn't, you'll notice that I then increment my position by 1, and then the next item I look at when I go through the list is going to be the one that's next along from that. And so that's how the linear search works. Have a good look at it, and feel free to flip it into a language of your choice. The second type of searching algorithm is a binary search. Now, this is favourable, although it does require you to have provided it with a slightly more organised set of data. Your list of data has to be ordered, essentially. And the reason for that is because of the way in which the binary search makes comparisons on the data in order to find what you're specifying, or hopefully find what you're specifying it looks for. And in order to better understand that, I'm going to show you another algorithm, and I'm just going to talk you through this. So again, we've got a list of items. This time you'll notice that they are in ascending order. Numerically. I then again request a search item from the user. I then have my found flag again, which is going to serve exactly the same purpose as it did in the linear search. I then have two variables, low ID and high ID. Low ID is set to 0 because that would be the position of the first item of data in my list. And then my high ID is set to the position of my last item of data, which is always going to be the length of the items I have, the number of items I have, minus 1, because the first item is always going to be in position 0. I then set a position variable equal to 0, and then I have my indefinite loop. Now, this is going to continue for as long as low ID is less than or equal to high ID and found equals false for the same reasons as before. What this then does is it then takes my low ID value, which is going to be equal to 0, my high ID value, which is going to be equal to, if you think about 1 being in position 0, we've then got 1 is 2, 2 is 3, so on and so forth, 0, 1, 2, 3, 4, 5. We add 5 to 0, which is going to give us basically 2.5. And then what we do is we take the whole number part of that, which is going to be position 2. Now, position 2 in my list is essentially looking at the number 3. And I want you to imagine for a minute that we're searching for the number 2. What this then does is it looks at the number 3, which is in position 2, and it says, is this equal to my search item of 2? Well, it isn't. And now what it does is it then decides, well, if it isn't equal to it, and I haven't found the value, I'm now going to check whether or not my search item is less than the value that I've currently got in front of me. Because if it's less than the value I've currently got in front of me, I know that it's going to be in one of 2 remaining positions. If it's not less than the number I've got in front of me, I know it's going to be in a remaining one of 3 positions that I've got, that being the numbers the other side of 3. And so this is working in a much more useful way, a much more efficient way, provided the list is sorted, because it's only ever looking at really half the numbers that are inside of the data list. And so what it would then do, if we carry on with the example I've given you, we look at the number 3, it's not the number we want, so we now reassign the high ID to be equal to the position we're currently looking at, which is 2, and we make it equal to essentially 1. And we now go back and complete the process again. Divided by 2 gets 0.5, because 1 plus 0 is that. We take that down, that's position 0. We're now looking at 1. Is that the case? No, it isn't. And so this process would then be repeated time and time again until we get to the value that we're looking for. And so this is a much quicker way of being able to find an item, or the position of an item, inside of a list of data, but it does require that you have got an ordered set of data in order to do so. As a summary, and linear and binary search columns there for you, the linear search can be performed on any list of data, which is the major plus point. So if you're looking at a data set which has got a mixture of values in with a mixture of data types that doesn't appear to be in any sort of order, you either need to go and provide an order for that data first, or you just go with the linear search. The linear search will check every item sequentially until the value has been found. It is summarized as being slow and becomes slower as the list of data grows, as the more items being checked grows. Whereas a binary search can only be used on an ordered list of data. It uses random access to look at the items in the data list, discarding half of the remaining list each time the value is found, or the 2 searching points meet. Remember, if a high equals our low flag, I should have mentioned that a minute ago. If ever your 2 flags are observing the same value and you're not looking at the value you want, then you can be safely assured that the value doesn't exist inside of the list of data. And finally, it's considered to be faster, and the speed of search isn't affected too much by doubling size of the list of data, because if you double your data size, you're going to be discarding half of it after the first search anyway, and so therefore you are only talking about 1 additional step. So there's the summary: binary faster, but you need it ordered; linear slower, but it will search a data set for you regardless of how many values you have in it and whether or not they are ordered.